All right. Nice to see you here today, Brent. Thanks for catching up with
Thanks, Jeff.
AHUG.
Good to see you too.
We have this AHUG kind of ARM sync here, so we just wanted to kind of
welcome everybody. We're you're in Atlanta and I'm at SC'19 on the show floor still. I didn't leave.
Right.
I like SC that much. I'm still there.
Yeah, sadly, this is the picture behind me is the closest we'll get to SC'20 in Atlanta, but hopefully we'll be back at some point.
Yes.
So we're glad to be able to do this virtual event. Even though we aren't able to meet in person, we have this nice slate of content that is hosted by AHUG, and I think too ARM has made a great contribution. So today we just want to talk a little bit about some of the exciting developments going on in the ARM world, and sort of how those tie back to experiences that ARM users can work with in the future.
So let's start with congratulations on being elected El Presidente for AHUG. That's great. It's exciting to see the group form and to get its legs under it. And this is your first event, right? So it's exciting.
Right, that's correct. Hopefully in the future we'll have a yearly user event, obviously in person, when it's safe to do that. Yeah. But we're very lucky to have a strong slate of directors that were elected. So we have 5 other directors that are helping out with AHUG, kind of helping to build the community. We're kind of getting our feet settled. So we have mailing lists, LinkedIn groups, obviously these events, the YouTube page, and things like a Slack, hopefully in the future, just for people to kind of get together and talk about ARM experiences, and also express their interests, to try to provide some feedback to ARM vendors and solution providers.
Yeah, that's great. So it's modeled after CUG, and I have to admit my age here. I went to my first CUG, I think in 1991 in Berlin. Was my first trip to Europe. It was exciting. It was huge. It was overwhelming. The technical content was excellent. I got to give a talk there. I think I was doing the precursor to Slurm at the time, doing the time scheduling system that Livermore worked on. It was fabulous. And CUG obviously lasted for several decades. And a toast to you. Hope that there's several decades in front of this organization. Whether or not you want to be at the helm for several decades, I don't know. I won't commit you to that, but right. Hopefully it's got a great future in front of it.
Right. Yeah. That's hopefully we'll have some other great leadership, but definitely, I think that's a good parallel. We do owe a lot to other groups like CUG and Linux users groups. And I think it's interesting that the AHUG name has been around for several years, and there actually have been some really nice events that sort of precede the nonprofit. But really, we would just like to build on some of that previous enthusiasm, and like you say, hopefully a future Brent, someone else in your position will be able to present at AHUG and many years later look back and see that as a formative experience.
It does feel like a good, smooth transition, so I'm excited for it. This is great news. So let's the other big thing that I wanted to bring up is congratulations to Riken and Satoshi and Fujitsu for their #1 showing that came out at ISC this year. That was super exciting. It's a bit of a step function in terms of the performance gain in the top 500. And of course, we're all out hands-on with systems trying to learn what we can about that high bandwidth memory and how it feeds the 2x512 SVE units. And there's a bunch of machines being sprinkled around labs and universities around the world, both from Cray HPE with their software stack, as well as from Fujitsu with their software stack. So there's 4 environments that are active right now, and I think another one coming with probably support from NVIDIA. So a lot of tools available, a lot of compilers available, and people are learning full speed here, trying to figure out, the value of the system and what it really brings to the community. So that's a really exciting development over the past 6 months.
Right. There's nothing like a leadership class system to say, hey,
Yeah.
A64FX is the #1 in both LinPack and HPCG, to kind of say, hey, take a look at this for your own deployment. And I think it's really exciting that we're seeing, not just the supercomputer variant, but we're seeing a bunch of different variants that are being deployed with the same processor, and of course tool sets to support that.
So the one I've watched a few of the talks, and one of the talks that really struck me as interesting was Satoshi's talk, because Fugaku is well ahead of schedule. I think it was supposed to be accepted next spring, but they've already deployed it on COVID-19 stuff. And his talk is really interesting because they go into the aerosols and how COVID is spread and what sort of masks. At the end, he talks about having a mask that's shaped to direct your breath away, that the humidity in the air matters a whole lot. There's some really fascinating stuff that they're learning based on that machine. And so it's, it's being put to use early and is hopefully going to help all of us with this zombie apocalypse that we're facing these days.
Right. Well, not on the SC'19 show floor, but SC'20 timeline.
You warn me if I have to turn around and run if you see any zombies sneaking up behind me, will you?
Yeah, I think that's very exciting that and we talk about all these with all the problems that we've had this year and all the loss and devastation. It's been amazing to see that we're able to kind of focus our computing efforts to tackle one big problem for humanity. And I think Fugaku and Satoshi's talk goes really into depth of how they use the simulations to try to support this effort.
But even the wider effort where there's all sorts of centers donating time on their systems to help with COVID, that's really the HPC community rallying around saying it's not about competition. This is important. We got to fix this. We got to do the best we can to help people understand it. So, applause to the wider community on that front.
Right. Yeah.
So the next thing I wanted to bring up with you, and it's not, I don't know if it's going to be on the agenda or not, but the other news in the past few months is that ARM unveiled a little bit more of a roadmap. And so the main thing for the HPC community is the naming and unveiling of our Zeus product. We talked about Zeus in the past, and we've now officially named it as V1, which is a performance class of IP. And it includes a 2x256 implementation of SVE. So this is in the Neoverse line of product. And what that means is that as a customer, a silicon partner, you can come license the implementation, the IP, which is different than just licensing the architecture. Fujitsu went and got an architecture license, which is effectively opening them up to the assembly language, and then went and did their own implementation. And so others are using the Neoverse IP and doing an implementation where they get to modify around the edges more. So the sizes of the caches and the amount of IO and so on. And the first couple of those that have come out, of course, are not Zeus, they're based on previous generation, but are the Graviton 2 processor from AWS and the Ampere offerings. There's a few offerings from Ampere there that are based on the Neoverse IP. And both of those are looking really incredible as well for HPC. The thing is, they're not pointed at HPC, but what we're finding is HPC apps just make, install, and run, and you actually get a reasonable percentage of the performance out of the chip. The Ampere guys are funny. They say, if you got an old dusty deck code that you don't actually want to put effort in, bring it over onto the Ampere silicon, and you're going to get reasonable performance, and you don't have to do anything with it. It just compiles and runs because the software is so stable and that chip is so performant across the board. So that's really good news.
Right. And do we see that those might also be used in some kind of emerging HPC, so stuff like edge computing or or where you might deploy it as part of a Kubernetes type cluster?
Yeah, they're predominantly in the cloud space. And, you know, as you know, cloud is trying to move into HPC and soak up some of the you know, long tail of HPC, perhaps some of the stuff that doesn't actually need vectorization. And there's a lot of it. You know, I've seen some of the numbers from the cloud guys, and they're making a lot of money in that area. And they're, if you talk to the folks from Hyperion, it's additive to the market. It's not pulling the legs out from under the traditional HPC data centers. It's opening HPC up to a broader audience and bringing a lot of revenue into the cloud companies. So it's very synergistic and very positive. But again, it's on the N1 platform, which we also announced the N2 platform, not with SVE, more of a data center cloud type thing. And so you can see down the road on the roadmap that there's some pretty exciting technologies coming along and more applicable to our community as we grow that forward and as we gather more silicon partners. It's really an exciting time to be at Arm here.
Right, that does sound exciting. So when can consumers start to see some of these things show up? And obviously, you know, Graviton, and we have kind of the initial versions in AWS, but you know, do we have any idea of when we'll see some of these other things show up in future data centers?
Well, so I think Ampere is shipping now. So I think those ones are, you know, in hand, although I hear that they're selling faster than they can pull them out of the oven. So that's great on the Ampere folks. You know, another aspect of that I think is super cool is that processor, the Ampere processor, has PCI Gen 4. And our friends at NVIDIA just announced their A100, which coincidentally was called Ampere, which drove us all nuts as we were trying to figure out which version they were talking about. But Ampere on Ampere, you know, is likely to be a real thing, and it's likely to go like gangbusters because Ampere, the company, put quite a hefty amount of PCI lanes on that chip. And so I think you can stuff a lot of the A100s in there. And so waiting to see what all that looks like when it comes out, and especially the software environment. You know, speaking of software, one of the things I wanted to mention is that Carl Schultz and the Open HPC effort, he gave a talk on that in this session, and kudos to him. He's been running that and making that go and supporting the ARM community all along. It's just, you know, such solid, excellent, fundamental, really required work that we try hard to support him, but you know, you have to spread your money around a little bit, and you don't get to. He's not drowning in hardware resources, right? He's having to be frugal to make it all work, but he pulls it off. Right. He makes it happen.
Yeah, I think that's definitely a key component of the ecosystem. I know one of the things when we recently deployed a very small ARM cluster is you know, looking for the right packages, and then just kind of happening upon Open HPC and saying, oh man, you know, everything's already here. Like just install this repo and we're good to go. So that's a big step in terms of supporting these new types of processors.
You know, the whole software environment, it's completely on fire on the cloud side. There's thousands of packages that are all in action and being ported and being optimized. So, you know, from the HPC perspective, these odd things that we need, they're often just covered by the cloud guys, and we can just go get that package and go to town with it.
Well, are there any other companies that are looking at this type of not necessarily architectural license, but looking at the Neoverse type cores? Are there any that you can talk about today?
Don't think there's any we can talk about, unfortunately. I haven't studied which ones are public and which aren't, so I don't want to misstep there. I can talk a little bit about Zeus and know that there are several HPC silicon interests that have licensed Zeus, and one of which was going to be on the show, not this one with you and I, but this AHUG event, and just couldn't quite get the legal approval. So they're right on the edge of starting to announce who else has signed up for it. Of course, Silicon Pearl is the public one. Those guys have been been public about it for a couple of years, and they're off to the races there in the EU doing the European Processor Initiative work.
Right.
I think, a little bit further abroad with the N1 and the N2, there's been a significant interest out of the hyperscalers. I think Amazon's leading the way with their Graviton implementation, but I can assure you that the rest are keeping close tabs on that sort of activity, and they won't be left behind for long.
Right.
So I think the future for ARM here looks really strong.
Right. So yeah, there's more in the pipeline. In other words, that
Absolutely.
hopefully as we get to ISC and SC next year, we'll be able to say a little bit more about who is actually deploying those new product lines.
That said, it takes a while to get hardware through the pipeline and out of the oven,
Sure.
right? I'm a software guy, and so it's like, let's get that Rev 0 up so that there's a heartbeat and we can start testing out things. But with hardware, it's a step function. You do a whole lot of simulation and try to get it perfect the first time, because once it's in the oven, there's no undoing that thing.
Right.
So we got to be patient, right? A lot of people have approached me and said, wow, you've got the #1 system on the top 500. It must feel great. And I'm like, yeah, but there's 498 others. I know there's
right.
The Sandia machine is still on there, but there's a whole lot of market expansion to do there. I don't think that this is the end or even the end of the beginning, right? We've still got a steep mountain to climb in front of us, but it's an exciting one, right? ARM is busy changing the business model that empowers others to go off and build technologies that are applicable on a broader scope to where they want to be. So it's a really cool time to be in HPC, to be in architecture, and specifically to be at ARM.
I agree.
So are there any talks? Have you watched many of the talks yet? Is there any that stand out to you?
Sure. I've gone through a few of the different talks here. We have kind of a great slate, so obviously I haven't made it through all of them yet. But I think we have kind of a nice mix of, we have some vendor talks. So we have one that I watched just today from HPE that's talking a little bit about the Catalyst program and some of the challenges in terms of just coordinating across different universities, bringing together TX2 type architecture. And then also Michelle Weiland from EPCC kind of has a follow-up talk to that, which actually says, okay, we had a lot of infrastructure build-up that we did, trying to get networking and drivers and things to work. So Ben Bennett has a nice talk on that. Then Michelle actually has a talk that goes into some of the science that is actually done, using those systems.
Right.
So now that they're up and running, they kind of have been prototyped, and they're actually ready to run.
And Simon McIntosh Smith does a good talk about the performance, and hopefully I'm not misquoting, but I think one of his quotes was, "It's just a supercomputer, and the users don't actually feel any different, right? It just looks like the rest of them." Which faults in my favorite quote from John Masters is, the applications guy doesn't care what the silicon is underneath. He cares the turnaround time on his job and what it costs to run it. I think that's one of the strong statements that's being made here, is that the ARM systems can roll in and get the software stack on them, and the users don't need to care whether it's ARM or not. Now we're going to try and get more advantages in there, right? Cost, power, performance, all that. But the ARM systems hunt today, which is super exciting to me.
Yeah, so there's several very nice kind of on-site talks. Obviously, you mentioned Simon's. There are a few talks, from sort of the admin's perspective, and from the kind of the sort of end user, not necessarily scientist, but computer scientist perspective, and then obviously domain scientists. So we have some nice talks from some of the DOE labs in the U.S. So we have one from Ross Miller at Oak Ridge. He's talking about their experience deploying the Apollo 70, Apollo 80. I thought that was really neat in terms of just comparing that, with the Catalyst UK, and kind of, they're deploying a very similar system, but had a few things that were similar, and then some differences. you know, in terms of their setup.
And there was a
then, of
talk by
course,
John Stone that was interesting. John Linford had directed me to that. He seems pretty happy with his experience, especially with SVE. So that one's worth watching to pick up those nuggets.
Right. So in terms of porting those big packages over, like NAMD and BMD, you know, John has a lot of experience, obviously, with many different generations of systems. You know, all the blue jeans, and now kind of getting his perspective to porting to, you know, a new ARM supercomputer is pretty neat, because he has all that context from sort of all the previous versions of this software.
Definitely someone worth listening to. He's got previous scars, and he's not scared to share them and tell you the warts that maybe here today, the here and now.
Right.
Well, that's good. I think we've got a very full agenda, lots of talks to watch. I'm looking forward to the roundtables on Monday. I'd like to thank everyone for spending their time looking, and I'll let you close. It's your show.
Well, thank you, Brent, and thank you everyone for joining us and for watching these talks on YouTube, engaging with us via the panels that'll be on Monday, November 9th. Obviously, if you watch this after that, then it's a little bit out of date, but we'll record those and have those available. You know, please engage with us, the Arm HPC users group, via our mailing list, via LinkedIn or Slack. And, you know, we're really excited to see your work, hopefully in coming years. So, you know, hopefully I'll be back in person with Brent here for SC'21, and we'll be able to talk about some of your videos as well. So, well, not videos, hopefully in person talks.
In person, yes. Back to real life. We'll get to see what people look like in 3D again.
Right. Let's see how we've all changed since we're not digital. But thank you, Brent, for your time.
Thank you. Great to be here. Great to see you.